Welcome all the student. We are going to be see the discussion about the basics of organic chemistry. In basic of organic chemistry, we are going to be discuss about the dipole moment. What is the dipole moment? What are the different applications of the dipole moment? That we are going to be seeing into this video. So the dipole moment. The molecules having two equal and opposite charges separated by a certain distance are said to be possess an electric dipole. That means any molecule which is having the opposite charges like plus and minus, and they are going to be separated by some distance, are said to be possesses an electric dipole. So the extent of polarity in such a covalent molecule can be described by the term dipole moment. So that means in some of the molecules like carbon-carbon bond, in which both the atoms are carbon, both are equally electronegative, having the same electronegativity of the carbon. In that case, a bonded pair of the electron which is shared by both the carbon atom equally, so there is no distribution of the charge. But in some of the cases, due to the slightly more electronegative atoms attached to that particular bond, will be responsible for the attracting more electron density towards itself, and which is responsible for the creating the dipole inside the molecule. So dipole moment can be defined as it is the product of magnitude of the charge and the distance of separation between the charges. So it is represented by the Greek letter m. Mathematically it is equal to the dipole moment, which is nothing but charge multiplied by the distance separation. It is expressed in the unit of dBi and as written as the d. So it is also called as the mu as the dipole moment. So it is expressed in the unit of the dBi. So dipole moment is a vector quantity and is represented by a small arrow with a tail at the positive center and head pointing towards the negative center. So it can be easily shown by some of the vector quantity as an arrow which is going to be contain head and tail. So in dipole moment, which is defined as the amount of the charge separation multiplied by the bond length. So charge separation is shown by an electrostatic potential, where red indicates the partial negative region and the blue indicates the partial positive region. So this is the molecule. We have not shown it by the red or any of the arrow. So this is the chloromethane, in which carbon has been going to be bonded with 3 hydrogen atom, 1 chlorine. So because of the more electronegativity of the chlorine with respect to this carbon and all other hydrogen atom, chlorine will try to withdraw the electron density towards itself, making it slightly partial negative charge. So as soon as it is going to become partial negative charge, the next carbon atom is going to become the partial positive charge, and this effect can be shown by this arrow, that is called the dipole moment, so which is denoted by the mu. So this indicates what the electron pair shared by the carbon chlorine bond will be shifted slightly toward the chlorine, towards the more electronegative atom. So this is the more electronegative center, whereas this carbon which is going to be having the partially electropositive center. So this molecule is going to be exhibit the dipole moment. So we have some of the example of the compounds which molecule can show the dipole moment and which molecule cannot show the dipole moment. So first example is the chloromethane, which is having like the tetrahedral geometry, in which carbon hydrogen 3 bonds and carbon chlorine 1 bond is there. So if we will see this, in carbon hydrogen bond, carbon is slightly electronegative than the hydrogen. So carbon will try to withdraw the electron towards itself, making this arrow. So all the 3 hydrogen atoms in which carbon is more electronegative will try to withdraw electron towards itself. But in case of the carbon chlorine bond, chlorine is more electronegative than any other atom in this molecule, making the chlorine as the slightly withdrawing the electron density towards itself and making the polarization in the bond. And if you are going to be see the overall dipole moment of this molecule, these 3 hydrogen atom contribute toward the carbon, but chlorine is going to be withdraw this one. So see, electron density withdraw by the chlorine is more than contributed by the 3 hydrogen atom. So that's why this molecule is going to be exhibit the net dipole moment due to the chlorine atom, which is the mu is equal to 1.9 dBi for the chloromethane molecule. Second example, which is a carbon tetrachloride. In case of the carbon tetrachloride, all atoms which are attached to the carbons are chlorine. So all 4 chlorine will try to withdraw the electron towards itself. But due to this tetrahedral nature, so these 3 chlorine atom will withdraw the electron towards itself, and the remaining 4th chlorine will also withdraw the electron towards itself. So the overall is going to be this dipole moment of this chlorine will be cancelled with all these 3 chlorine. If we'll say the overall dipole moment of this molecule, so making the overall dipole moment of this molecule will be 0. This is a carbon tetrachloride. But the same molecule, a slight modification, with we are going to replace one of the chlorine by the hydrogen. This is going to become the chloroform. In this case, the electron density which is going to be withdrawn towards itself by the 3 chlorine atom is not going to be cancelled by the electronegativity of the hydrogen atom. So what is going to be happen? The overall electronegativity is going to be shifted toward the chlorine, making this molecule as a dipole in nature. So this is going to become a mu is equal to 1.0 delta. The example is the chloroform. So many of the times it is going to be very important, the geometry as well as the structure of the molecule is going to be decide the dipole moment, as well as the substituent which are going to be attached to that particular carbon is also going to be decide the dipole moment of the molecule. So the molecular dipole moment is the vector quantity, again depends upon the bond polarity as well as the bond angles. Lone pair of the electron contributes significantly towards the dipole moment. And if you are going to be see these all 3, these are the all same example, methane tetrahedral geometry, but all are the 4 hydrogen. The dipole moment of all these 3 hydrogen 1, 2 and 3 will be equally cancelled by the 4th hydrogen atom. So mu is equal to 0 dBi. But in case of the carbon tetrachloromethane, same is going to be happen. These all 3 chlorine will try to withdraw electron towards itself, but one of the chlorine which is on opposite side withdrawing the electron towards the opposite side. So the dipole moment which is going to be happen due to all these 3 chlorine will be equally cancelled by this chlorine. So the overall dipole moment of this tetrachloromethane or carbon tetrachloride will be 0. Same is going to be happen in case of the ethane. So as in a previous slide we have discussed that geometry, nature or the structure of the molecule is going to be contribute largely for the dipole moment. In this case, the dipole moment for all the 3 hydrogen atom at the top will be cancelled by the same this one, making the ethane as the overall dipole moment will be the 0 dBi. So these are some of the molecule we are going to be observe with the increasing polarity. So as dipole moment is going to be increases, polarity of the molecule is going to be increases. In this is carbon-carbon bond, second one is carbon-nitrogen, carbon-oxygen, carbon-chlorine, and we know that chlorine will be more electronegative than oxygen, than nitrogen. So in this case, the chlorine is going to be exhibit the highest dipole moment than oxygen, than nitrogen, than carbon. So that's why as we are going to be move towards this arrow indicated as polarity is going to be increases, the ionic character is going to be increases. Ionic character is going to be increases. Effect of branching on the boiling point. So branching is also responsible for the decreasing of the boiling point. So this is also going to be having the dipole moment. During the dipole moment, how molecules are going to be orient towards itself, what is the stacking of the molecule can also decide the boiling point and all other effect. So as branching increases, boiling point of the compound increases. So what is the effect of polarity on the solubility? So as we know, the basic concept of the organic chemistry is like dissolve like. That means polar compound dissolve into the polar solvent, non-polar compound dissolve into the non-polar solvent. So it is like dissolve like. Polar solute dissolve in polar solvent, non-polar into the non-polar solvent. Molecules with similar intermolecular forces will mix freely. So this is what we have discussed, that dipole moment is going to be arises inside the molecule due to the more electronegativity of one of the atom into that bond. So if you like the content of this video, you can share this video, you can like this video, as well as you can subscribe my YouTube channel. Thank you.